Guys, good morning. So we are in the very latter part of the lesson, right? Sorry, got a little late, but don't worry, we are in the right track and in the right time zone. So that is only my fault, and I'm really sorry for that. And yeah, we discussed a few of the questions and gave you one of the homework questions as well. Yeah. Yeah, this is all finished. I couldn't find the right. All finished. This was homework. Was it? No, the other one, right? This one. That's all finished. Sorry, kinetic ones, right? Yeah. This was homework. This one, right? Yes. Yeah. So quick recap what we so far studied. Even the last week you were there, right? Yeah. So we discussed what? What did we discuss? Good. We discussed about the stoichiometry, and it's a very important part and a bit of a. There is a that could be the trickiest part, and it's somewhat not that hard, but that is the trickiest part of the lesson, right? And we discussed about the rate of reaction. If we start from the very beginning, rate of reaction is important, and it doesn't have to be always fast. It has to be optimum. That's all. Yes. And when it comes to the rate of reaction, there's two ways. There are two ways that you can measure it. How do you do that? You measure the rate of reaction using the rate of consumption, that is depending on the reactants, and you measure the rate of reaction using the rate of formation, that is using the products. Yes, but though we calculate it using the reactants and the products, the rate of reaction is not same all the time, isn't it? Yeah, can remember, right? So the rate of reaction changes because of what? Because of the stoichiometry. Good, very good, right? You have to have that in mind. Very good. And if the rate of reaction is a minus value, that's a rate of consumption, that is depending on the reactants, and because of that we put a minus in front of the formula, right? So the rate of reaction formula is final minus initial divided by time. It could be products, could be reactants, right? And there is a simple formula: R equals delta N over delta TO. R equals delta concentration difference, which is a square bracket, divided by time is there, right? Those two of the formulas were there. So you have all that in mind. Yes? No. You were absent. Doesn't matter, right? So you know it already. You don't know it already? Doesn't matter. So you have to catch it up from here, right? And we are supposed to discuss the average rate of reaction and the factors affecting the rate of reaction, and the necessities for a reaction to occur. Few of the theories are there, and we will further discuss those. Very important parts. Oh, methanol. You don't have to worry. We are in the very beginning. Yes. So coming to this question, NO2 is converted into NO gas and O2, right? NO2 gas is converted into NO and O2. Yes. So the initial concentration of NO2 is given how much? 0.01 moles per decimeter. In a closed tube, after 100 seconds, the concentration of the NO2 is 0.0065 moles per cubic decimeter per second. What is the rate of formation? They are asking what is the rate of formation, right? So the initial concentration of NO2 is this, and the final concentration of NO2 is this. So using that and the time given, you can calculate the rate of consumption of NO2. You can, right? Because the concentration difference over time is the rate of reaction here. But the question is asking what is the rate of formation, right? What is the rate of formation is the question, and it's supposed to give a rate of formation of IR. Yeah, so they are asking the rate of formation. So it's supposed to be the rate of formation of NO, let's say, right? It's supposed to give, because we don't know what is forming, right? So there's two of the components which is forming, NO and NO and O2. So the question is supposed to ask which exactly, either NO or O2. So we'll take NO. But did you take NO or the O2? Mm-hmm. 3. Okay. So we'll first calculate the rate of formation of rate of consumption of NO2. So that is RNO2 equals delta concentration difference of NO2 over time. So you have to apply the values here. The final is 0.0065. If I round off it to a 1 decimal, that will be 123, 6.5 into 10 to the power minus 3, 123, right? I took like 10 to the power minus 3, 6.5 minus the initial is what? 0.01. So if I take the same power, that will be 1, 2, 3, 10. This is the final, right? Initial is this. This is the final. Yeah. So yeah. So 10 into 10 to the power minus 3. 1, 2, 3. So it's 10 into 10 to the power minus 3. Divide by the time. How much is the time? After 100 seconds. Time is 100 seconds, right? And since this is a rate of consumption, is supposed to put a minus value in the front, right? You have to put a minus value in the front. So there will be 6.5 minus 10 is how much? 3.5. Yeah, 3.5 into 10 to the power minus 3 divided by 100. 3.5. 3.5 10 to the power minus 3 divided by 100, right? And that will be how much? 3.5 into the 10 to the power minus how much? If this was taken to the top, that will be 10 to the power minus 2. With combining with 10 to the power minus 3, the whole thing will be 10 to the power minus 5, right? So 3.5 into 10 to the power minus 5 is the rate of consumption of NO2. Because the stoichiometry is equal of NO and NO2, the rate of consumption of rate of consumption of NO2 and rate of formation of NO should be equal. So did you take that answer? Okay. Is this answer also there for the oxygen? No, right? You didn't take that. Okay. 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 The NO it is. So if the question is asking for the formation of O2, then it should be half. You have that knowledge, right? Even the online people, do you have this knowledge that if the question was asking for the formation, the rate of formation of oxygen, that should be half of this, because the stoichiometry is 2 to 1, right? So 2 to 1 means the rate of formation is half of it. Get it? Good. Very good. So the answer is what? You will be fine, don't worry, right? 3.5 10 to the power minus 5 is the answer. Yes? Right. So that is rate of formation and rate of consumption. We did the calculations. Now this is one of the very important parts, the average rate of reaction, right? So average rate of reaction is the common rate of reaction for the whole formula, right? That is the common rate for all the reactants and for all the products formed. It has to have a common value, a common formula, a common equation for all the reactants and products that gives the same value. So if we take the rates of these reactants and products, when the stoichiometry changes, the rate of reaction change, right? But we now need like a certain exact same rate of reaction for each and every reactant and product. So what is bothering us now? To take a common and a even rate of reaction for all the reactants and products. What is the factor that changes the rate of reaction? What factor changes the rate of reaction here? Stoichiometry. Yes? Yeah, right. Stoichiometry is the factor that changes the rate of reaction, right? So how do we get rid of it? How do you get rid of it? We remove the remove that factor. How do you remove that factor? Can you remove the stoichiometry? No, it's there in the reaction. That is the ratio how it reacts and the products are produced. So how do you remove the effect of stoichiometry? That is the important thing. Oh, I told this to me, think at home. Now online people, how do you remove the effect of stoichiometry for the rate of reaction? By what? Divide them by same number. Now let's come to the one of the. Okay, so if we come to this reaction, how do you divide it by, let's say you are dividing it by the same number. So if you are dividing it by the same number, this will be 1, this will be 1. This will be again half. Yes? How do you equal the everything? This is very simple. කාටද? O2 එකක් ඇඩ් කරනවා. මේ පැත්තට? එතකොට unbalanced. So the rate of reaction, do you see that the simplest or the simplest ratio here is 1, that is of oxygen, and all the others are like multiplications of that, right? So if the simplest ratio is 1, what if we take everything into 1? That is the question. How do you take the, like අපි තුමු මෙයාගේ rate of reaction එක අපි හොයාගත්තනේ. We found the rate of reaction of this as the half of this, right? මෙයාගේ half කියලානේ අපි ගත්තේ. Right? එතකොට ඊට වඩා මෙයා වැඩි වෙලා තියෙන්නේ කීයකින්ද? by 2. මෙයා වැඩි වෙලා තියෙන්නේ ඒකත් by 2. right? එතකොට මේ දෙන්නාගේ rate of reaction එක අපි stoichiometry එකෙන් divide කරොත් එයාගේම stoichiometry එකෙන් divide කරොත් by 1 වල එකකට equal වෙනව නේද? නේ? So what do? You divide the rate of reaction by the stoichiometry. So everything will become 1 relatively to the 1. You said what? You said dividing by the same number. No, you don't divide it by the same number. What do? You divide it by the stoichiometry of the reactant or the product. So it will become 1 because stoichiometry multiplies it. Get it? Oh, again මෙයාගේ rate එක 2 වලින් divide කරනවා. Bro, you said the same number. It's like you divide the whole thing by 2. You said that, right? You said that. Yeah. So this is a different case. You divide it by the stoichiometry because the stoichiometric multiplication increases the rate or gives the rate. මෙන්න මෙයාට stoichiometry කියන්නේ. හැමදෙස්සම මෙයාගේ මොලිකියුල් එකක ඉස්සරහා තියෙන එක නා තමයි stoichiometry. මේගොල්ලෝ නෙමෙයි. හොඳේ මේ 2 ඒගොල්ලෝ නෙමෙයි. මෙන්න මේ මොලිකියුල් එක ඉස්සරහා තියෙන number එක we call it stoichiometric value, right? එතකොට එයා තමයි හැමතිස්සෙම rate of reaction එක multiply කරලා දෙන්නේ value එක නේ. ඒතර අපි ආව එයාගේ stoichiometric value එකකින්ම divide කරොත් ඒක 1 වලට relative වෙනවා. Get it? So if you want to take an average rate of reaction or a common rate of reaction for each and every reactant and product, what you have to do is you write the same formula the same way and you put the reciprocal of the stoichiometry in the front. So it divides and gives the relative rate of reaction for 1, stoichiometry 1. Get it? That is how you do it, right? So average rate of reaction, what you have to do, simple thing what you have to do, very simple thing, to find the average rate of reaction, you have to write the formula the same way and put the reciprocal of stoichiometry in the front. That's all. Get it? Simple as that. It's a very simple thing. Understood it? Yeah, right. So the simple way to remember is what? You write the same formula and you put the reciprocal of the stoichiometry value in the front. So you get the average rate of reaction. And when it comes to the average rate of reaction, all the rates are equal, right? That is what the average rate of reaction is. All the rates are equal because you are taking the average rate of reaction for the stoichiometry of 1. අපි 1 වලට relevant වෙන විදිහට ගන්න එක තමයි කරන්නේ. Right? Right. Right. So average rate of reaction. Online people, did you understand the theory? Please say something. I'm still alive. Rishmita, Shanal, yes, good. Shanal understood. Shiny, understood it. Malshi, yeah, Malshi there. Malshi there. Rishmita, yes, good. Now, if you have any doubts, you tell, because you have to move forward with the understanding. Otherwise, if you lose it, it's very hard to take it back. You like clean it up at the point. It's the best way. Don't take it home, right? Right. Finding average rate of reaction. When finding the average rate, it can be obtained by writing the rate equation of the reaction as before and multiplying it by the reciprocal of the corresponding stoichiometry, right? Multiplying it by the reciprocal of the corresponding stoichiometry. Get it? That's how you do it. Yeah, simple as that. So finding the average rate gives a common rate for the entire reaction, and this is how you do it. So average rate of reaction, we'll take it R equals, if we are taking it depending on the reactants, minus should be in the front and the do you take your hand off? And the reciprocal of the, not yours, there. Why would you get, right? Minus 1 over what? 1 over? You're not focusing now. 1 over? That's okay, right? You're fine there, right? Because ඉස්සරහට එන්නේ ඉන්න වගේ බෙල්ල තව අමාරුයි. So you take 1 over stoichiometry. This n is what? Stoichiometry, right? 1 over stoichiometry, and the number of difference of difference of number of moles over delta T, right? If you take it by the concentration, R equals minus 1 over n delta concentration difference over time. This is depending on the reactants. ඒ reactants වලින් ගන්නකොට මොකද වෙන්නේ? minus value එකක් අපිට එන්නේ. ඒක plus කරන්න අපි minus එකක් ඉස්සරහින් දානවා. නේ? That is what we discussed. And if I'm taking it depending on the products, that will be R equals, is there minus තියනවද? Is there any minus now? Bros, is there any minus now? No. So it's 1 over just n delta n over delta T. R equals 1 over n. 1 over n is the reciprocal of the stoichiometry, delta concentration difference. This is the same formula that we wrote previously, right? Delta T, simple as that. Get it? So 1 over n here is what? The reciprocal of the stoichiometry. We have already defined these things, right? So you can write here in the bottom or somewhere up here, doesn't matter. 1 over n is what? Reciprocal of, yeah, of stoichiometry. Right. Reciprocal of stoichiometry. Yeah, quickly take a quick note. Right? Finish? Next one. Write down the initial reactant and final quantities involved in the reaction of 3 moles of O2 with 1 mole of glucose and find the average rate for each part of the reaction. Right? Can you do that? You have to find the final and the initial amounts that are reacting and produced. No worries. For now, don't think about it. Ask one of the people. Finish? Finish? No? Finish it. Online paper finished it? right? Right. So initial, this is reactive or reacting should be, this one should be reacting, not restrictive. Initial, reacting, final. So now this 1 mole to like the stoichiometry is 1 to 6, but the amounts available are like 1 mole of glucose and 3 moles of oxygen. So one supposed to be limiting. Yes, can you remember the limiting factor, that if one is less, if one is lacking to react with the complete amount of the other one, it becomes the limiting. You have to find it using the stoichiometry. So if I take the ratio is 6 to 1. So 3 to how much is reacting? We can take it both way. මෙහෙන් ගන්න පුළුවන්, අනිත් පැත්තෙන් බලන්න පුළුවන්. So if I compare it using glucose, හරිද? Ratio is what? 1 to 6. We call it අච්චරට මෙච්චරයි. Glucose, oxygen I'm comparing. That's 1 to 6. මෙච්චරට කොච්චරද? කොච්චරක් ඕනද? 6 is needed. What does it mean? It means to react with 1 mole of glucose, it needs 6 moles of oxygen. Is it there? No. So the whole thing won't react. So this becomes a limiting factor, that means, right? මොකද මෙයාගේ whole thing එක මේ react කරන්න මෙතන තියෙන amount එක මදි. So this is becoming the limiting factor. අපි මෙයාගෙන් බලමු එතකොට. මෙයාගේ ratio එක O2 to glucose is 6 to 1. 6 to 1. අච්චරට මෙච්චරයි. මෙච්චරට කොච්චරද? එච්චරට කොච්චරද? Half is reacting, or 0.5 is reacting. ඒ කියන්නේ මෙයාගේ 3 moles එක මෙයා කීයක් react කරනවද? 0.5 is reacting. So මෙච්චරක් තමයි react කරන්නේ. මෙයාගේ 3 moles ම react කරනවනේ. right? මෙයාගේ 3 moles එක මෙයාගේ 0.5 විතරයි react කරන්න පුළුවන්. 0.5 is remaining without reacting, right? Yeah. Huh? Yeah, you can take it that way as well. But better going through the stoichiometry. මේ stoichiometry එක ගන්න එක තමයි. ඔව් ඒක පැත්ත values දීලා නැහැ. නිතර stoichiometry එක ඒ පැත්ත ගන්න ඒකට ඕන වෙනවා කොහොමද? නේ? Good. So make a 6 to 6. So 3 to 3. If you take it from this, if you compare it with the glucose, 1 to 6. So 0.5 to, how do you take it? 1 to 6, 0.5 to 3. Will give the same answer, right? H2O, 6 to 6, 3 to 3. Making ගත්තත් එහෙමම තමයි ඉන්නේ. Same, but with 3 moles. මොනකටද? මේ දෙන්නටද? Because initially the products aren't produced. Only the reactants are there. When the reaction occurs, the products are produced. Initially reactants තියෙනවා. නෑ එහෙම හිතන්න එපා. ප්ලස් එක තියෙන්නේ රියැක්ෂන් එකේ. එහෙම නෑ මෙහෙම හිතන්නකෝ. This is the theory. හරිද? When at the beginning reactants are not reacted, so the products are not formed. Now that's the theory. You take it that way. හරිද? Don't go into the illusions. හරිද? හිතාගන්න එපා දේවල්. In the final amounts, this is 0.5 left without reaction, right? And this is completely reacted. 3 mole of this is produced and 3 mole of that is also produced, right? 3 mole of this and that is 33.3 of a percentage chemistry. Yeah, 33.3 of a percentage chemistry, so 100 වලින් ඉඩ කරාම කීයද? බෑනේ 75 යන්නේ. chemistry කියන්නේ 73.3. පල්ලෙහා courses වලට යන්න පුළුවන්. පල්ලෙහා courses වලට යන්න පුළුවන්. නා මෙහෙමයි. You have time, හරිද? You have time. I mean, like, there's a certain period of time you have, right? And try the maximum. And you decide it after where you're going, like Japura or Colombo, you have to decide it afterwards. You have to do your maximum. Like, show your maximum and like gain your maximum. Then you can go into anywhere. Maybe you can go, like, apply for a scholarship and go abroad. That you decide after. Haritha, don't decide it now. ඒ කියන්නේ ඒක රික්වයර්මන්ට් එක. සමහර courses වලට ළමයි රික්වයර් කරනවා වැඩි. සමහර courses වලට අඩුයි. රික්වයර්මන්ට් එක වැඩි මේකේ Z එක වැඩි කරලා දානවා. ඒතර මොකද හැමෝටම දෙන්න බෑනේ. ඒතර වැඩිම රික්වයර්මන්ට් එකක් තියෙනවා Z එක වැඩි. So those are two things. Yeah, I think the මට මතක නැහැ හරියටම Z එක. Z mark එක හදන්නේ ඔයාට වැලියු එකක් දෙන්නේ. ඒ කියන්නේ පේපර් එකේ තියෙන ඩිෆිකල්ටි එක අනුව ඔයාට වැලියු එකක් දෙනවා. ඒක ඔව් වෙනස් වෙනවා. එහෙම මේ සර්ටන් එකක් නැහැ මෙතනින් කියලා. පේපර් එක හાર્ඩ් වෙන විදිය අනුව Z එක වෙනස් වෙනවා. දැන් පේපර් එක ගොඩාක් හાર્ඩ් එකක් නම් සාමාන්‍යයෙන් Z එක පල්ලෙහාට ගන්නවා. හිතන්න Z එක දෙන්නේ 50 කියලා. එතකොට ඔයා 60 ගත්තොතින් ඔයාට Z එකට 10 marks add වෙනවා. 70 ගත්තොත් 20 marks add වෙනවා. ඔයාට ET අදාළ නැහැ. ඒක අදාළ නැහැ. නෑ. ඔයාට ඒක අදාළ වෙන්නේ නැහැ. කියන්නේ ඔයාගේ කොහොමත් මේ රෑන්ක් BST වලින් තමයි ඔයාගේ රෑන්කින් හැදෙන්නේ. ET වලින් හැදෙන්නේ නැහැ. BST වලින් තමයි ඔයාගේ රෑන්ක් එක හැදෙන්නේ. ඒතර ET වල Z එක වැඩි වුණත් අඩු වුණත් ඔයාට වැඩක් නැහැ. නෑ. කවුද? එහෙම එකක් නැහැ. That's how people are. People are not there to මාස කීයකට කලින්? ඇවිල්ලා ඉවර කළා. For real? That's how the people are. I don't know. ඒක හැටි. ඒක හොඳ දෙයක් නන් නෙමෙයි. ඉතින් ඒ කියන්නේ හැමෝම බලන්නේ අර let down කරන්න. නේ? මොකක් කරන්න තමයි. ඒ already down. ආ. That's the thing. The people are like that. හරිද? ඒකේ දැන් ඒගොල්ලෝ කියන එක ඔයාගේ මේ inner voice එකට දාගන්න එපා කොයි වෙලාවකවත්. හරිද? Keep your inner voice higher than those. හරිද? Always trust your inner voice and අර gut feeling එක try කර මේ trust කරන්න. ඔයාගේ inner voice එක high තියාගන්න හැමතිස්සෙම අර අනිත් අයගේ ඒවා inner voice එක ඇතුළට දාගන්න එපා. එතකොට හරි කචල්. හා? inner voice එක නැත්තම් හොඳයි. ඒ කියන්නේ මෙහෙමයි. Just take the actions logically. Let go of the emotions. You don't have to consider the negative emotions of them, negative impacts of them. Those are just the words. And you do your work logically. You think logically. If I do it this way, this will happen. If I do it this way, this will happen. So you know it. You know your outcomes, right? If you study, and when you are studying, you know the level of you, right? Because you are doing the questions. Yeah, you can always check it. Yes, you can always check it. That is why we are doing the papers, right? So you can check it always that if you are improving or not. can check all the past paper questions. I am giving you the past paper question banks, right? PPC. You can check it always. Even you can check it lesson wise, and you can even check it complete paper wise, right? So you know what will be your final result before you are answering the final exam, right? You can take a a certain measurement how will be your result, right? And that is how you should walk your path, with knowledge, with understanding. And if you are doing something without understanding, and that is disastrous, that is true. And people are just trying to mock you and let you down. That's their mindset. That's okay, that you leave it to them. But there's something that you have to take from there. So if they are telling that this will happen, you have to think about it. ඇත්තටම එහෙම වෙයිද? And you consider the factors. What are the factors? Am I studying enough? Am I understanding enough? Am I answering the questions enough? How are my marks? Have I improved a lot? And if I take the past papers, are those like very difficult that you can't completely answer? Or can I answer for a certain amount now? How much do I have to improve by myself? You have to consider the factors. And considering those factors, if you understand that I can do this, yes, you can do this. That's all. Just have a self-estimation that you can do it or not. And when once you understand it, that I can do this, you're just doing it. You don't care whoever are telling whatsoever the thing, right? Just trust on yourself. That is only about yourself, how you are reacting to it, and how you are improving yourself, and how you are getting everything in a process, in an order, and in a plan. That is something about that. That is something about yourself. And don't worry about the others. That's how the people are. I don't know. So now, if those people are there around you, don't take them to your inner circle. Keep them away from your inner circle. Don't take any of those the negative people to your inner circle. Just don't ප්‍රශ්න දාගන්න එපා. But keep them away from your inner circle. Don't have to listen to them. You don't have to listen to them. You can reject them. So I don't want to hear those. I have decided this, so let me do this peacefully. You just tell it and you get rid of them. That's all. You can genuinely tell it, because if something is trying to to let you down, you have a right. You have to have the courage to say no. And this is not like that. I am doing this with my knowledge, and I know what will happen. Doesn't matter if I be selected for a university or not. This is my challenge. I'm accepting it and I'm trying to do it. Doesn't matter if I fail or not. I'm doing this because this is what life is. Right? We have to take actions, and we'll take the further steps. How and when that happens, right? That doesn't matter. And I have but you can take the measurements. You can take the measurements. You can tell it, depending on the work you're doing, you can tell it if you are going to pass or not. Right? You already know. And I already know. So it doesn't matter, right? Doesn't matter. You don't have. But if in those cases, if somebody is trying to say something like that, you can directly say no. You can directly say no. That's okay. Right? So this is it. Did you write the rate of reactions? Yeah. So average speed or rate using C6H12O6, right? C6H12O6. So the final the average speed of C6H12O6 will be R equals 1 over. Is there a stoichiometry for the glucose? No, right? There is no stoichiometric ratio, so it's just this. It's minus delta N over delta T, and that will be, the final is 0.5 and the initial is 1. 0.5 minus 1 mole, and the time is 1 second, right? And the rate is how much? 0.5 mole per second, right? 0.5 mole per second. And the average rate of oxygen, right? 3 are reacting and the final is 0. So the R of oxygen, we can write RO2 if you want. Make it C6H12 O6 ke liyanna puluwan, equals delta N over delta T. Yeah. Final is 0, initial is 3 moles and the time taken is 1 second. So I put a minus in the front, right? And the answer is how much? 3 mole per second, right? Yeah. Glucose, sorry. Glucose වල 6 තියෙනවනේ. Yeah, sorry. Glucose වල 6 එක අනිවාර්යෙන් දාන්න ඕන. මම ඒක මේ 1 තියෙනවා කියලා හිතලා ගත්තේ. That was wrong, sorry. Stoichiometry එක oxygen වල තියෙනවනේ. Glucose වල 1, oxygen වල 6. මම ඒක මේ 1 තියෙනවා කියලා මතක තියලා මම මතක එහෙම හිතලා ගත්තේ. 1 නෙමෙයි 6 තියෙනවා ඒකේ. හරිද? ඒතර ගන්න ඕන -1/6 delta n over delta t තමයි ෆෝමියුලා එක ගන්න ඕන නේ. එතකොට -1/6 0 minus 3 over 1 second කියලා එන්නේ. එතකොට මෙයාගේ ආන්සර් එක ඉන්නේ ෆයිනල් ආන්සර් එක ඉන්නේ මේක සිම්ප්ලිෆයි කරාම පස්සේ කීයද? එතකොට නෝ 3 over 6 that is 0.5. ඔව් මෙතන තියෙන්නේ 1 over 6 into ඒක ඉතින් මෙතන this is enough. Multiplication කියන එකම තමයි මෙතන තියෙන්නේ. හරි. So that is 0.5. Right? What's the sound? Average speed using carbon dioxide. So it's production, right? Carbon dioxide is produced and its stoichiometry is also 6, right? Stoichiometry is also 6. So that will be RCO2 equals delta N, and you have to put the stoichiometry in the front, 1 over 6, right? 1 over 6 delta N over delta T. So equals 1 over 6. What is the molar difference? Initially 0, finally 3, right? So 3 minus 0 divided by 1 second. So it's a multiplication here. So the answer will be 0.5 mole per second, right? And the average speed with H2O, RH2O, right? RH2O equals, again the stoichiometry is 6, right? Yeah. So 1 over 6 delta N over delta T is the formula. So that will be 1 over 6 final minus initial, that is 3 minus 0, right? That is 3 minus 0 over 1 second. This is the multiplication, and that is 0.5 mole per second, right? 0.5 mole per second. Get it? Yeah. So now all the rates are equal, right? That is what you call average. That is what you call the average rate of reaction. People online understood it? Yeah. නෑ මේ විදිහට ෆෝමියුලා එකකින් යන්න ඕන. This is a step. Yeah, part 2 of this guy. One over දාන්නේ අර අපි කතා කරේ ස්ටොයිකියොමෙට්‍රි එකේ රේට් එක මල්ටිප්ලයි වෙලා තියෙන්නේ. දැන් ස්ටොයිකියොමෙට්‍රි එක 6 තියෙන හින්දා තමයි 1 කනෙක්ට් කරන්නේ. 1 over 1 කියන එක දාන්න ඕනේ. 1 ස්ටොයිකියොමෙට්‍රි එකක් තියෙන ඒවාට විතරයි අපි දාගෙන යන්නේ. right ඒතකොට වාට එන්නේ ඇවරේජ් එක කියන්නේ මේ හැම එකෙම දැන් rate of reactions ඔක්කොගෙම equal වෙලා තියෙන්නේ. right කලින් එහෙම equal වුණේ නැහැ. ඇයි? ස්ටොයිකියොමෙට්‍රි එක වෙනස් වෙනකොට rate of reaction එක වෙනස් වුණා. දැන් අපි ඔක්කොම equal මොකද ස්ටොයිකියොමෙට්‍රි එකේ action එක reciprocal කරලා තියෙන්නේ. එතකොට එයාගේ action එක නැති වෙලා යනවා. right right there are no negative answers for the final answer of the average velocity. right the factors that affect the occurrence of reaction. right this is a new theory. Now did you understand the average rate of reaction? That is very important. There will be questions on that. right good. right so the next thing, factors affecting the average rate of reaction. right factors affecting the average rate of sorry not average rate of reaction, the factors affect the occurrence of a reaction. How, like the factors that affect for a reaction to occur. Those are two things. Two of the topics are there. The factors affecting the rate of reaction is one thing, and the factors affect and reaction to occur are two things. ඔය දෙක mix up කරගන්න එපා. Factors affecting the rate of reaction is one topic. Factors affecting the occurrence of a reaction is another thing. අන්න හරි. ඔව් rate of ඒ කියන්නේ rate of reaction එක වැඩි කරන්නේ temperature එක, concentration එක, particle size එක ඒ වගේ ඒවා. හැබැයි occurrence එකට ඒ කියන්නේ reaction එකක් occur වෙන්න වෙනම factors ටිකක් තියෙනවා. හරිද? The factors affect the occurrence of a reaction, for a reaction to occur. right so these are the factors. We will discuss this. right come to the point. The factors affecting the occurrence of a reaction, these are the things. right now think it this way, it's very simple and easy. Now there's a plug, right? And this is a plug top or something, you see. It's a wire, it's a bulb, right? Now there's no light yet, but there's no light yet. This is the system. So you are going to now these are the reactants. මේ දෙන්න තමයි reactants දෙක. These two are the reactants. These two are the reactants. Plug එකයි plug top එකයි. These two are the reactants. And this is the product. අර bulb එක light වෙන එක තමයි final product එක. That is the product. ඒ කියන්නේ අපේ reaction එක වුණොත් bulb එක පත් වෙන්න ඕන. හරි. right so now මේ reaction එක වෙන්න නම් හරිද? for this reaction to occur මේතන මොකක්ද වෙන්න ඕන? මේ reaction එක වෙන්න නම් මෙතන මොකක්ද වෙන්න ඕන? ඒ දෙන්න connect වෙන්න ඕන. අපි එකට කියනවා collision එකක්. එතන collide වෙන්න ඕන. හැපෙන්න ඕන. first thing is the collision. මේ දෙන්න collide වුණොත් තමයි bulb එක පත් වෙන්නේ. So that is the first step, collision. කියන්නේ reaction එකක් වෙන්න නම් මේ විදිහමයි reactants දෙන්න මොකක් වෙන්න ඕනද? reactants දෙක collide වෙන්න ඕන. හරිද? මේක තමයි product. එතකොට මේ දෙන්න collide වුණොත් තමයි මේ product එක හැදෙන්නේ. So the first point is collision, right? First point is collision. Second point is what? මේ දෙන්න නිකන් collide වුණායි කියලා product එක හැදෙනවද? නෑ. කොහොමද ඒ? හරි ගන්න තියෙනවා. මොනවාද හරි ගන්න තියෙනවා? දැන් මේ ඕඩර් ටික අපිට මොකක්ද තව එකක් කියන stoichiometric ratio එකද? stoichiometric ratio එකෙන් අපිට කියන්න පුළුවන් ඒගොල්ලෝ complete react කරනවද නැද්ද කියලා. complete reaction ද incomplete reaction ද කියලා කියන්න පුළුවන්. limiting වෙන එක තමයි මේ කතන්දරේ stoichiometric. ඈ? voltage. I don't think of the voltage everything are there now. හරි. මේ කැලේ විතරක් හිතන්න. collision එක තියෙනවා නම් people on light is there has to be a collision, that is correct. මේ දෙන්න connect වෙන්න ඕන. collision should be there. What else? No. wire එක හොඳට තියෙන්න ඕන. No. ඒ ඔක්කොම තියෙනවා. ඔව්. ඒ කියන්නේ මේ දෙන්නගේ ඔක්කොම තියෙන්න ඕන අර ෆිසිකල් කන්ඩිෂන්ස් ඒ ඔක්කොම ටික තියෙනවා. මේ දෙන්නගේ රියැක්ෂන් එකක් වෙන්න නේ ඕන. ඒතර එකක් මේ දෙන්න කනෙක්ට් වෙන්න ඕන. ඒක හරි.
හරි ස්ටේට් එකේ තියෙනවා.
No. The second is orientation. ඒ කියන්නේ මේ ප්ලග් එක අනිත් පැත්ත හැදලා අනිත් පැත්තට ප්ලග් වුණොත් එහෙම බෑ. නෑ නෑ නෑ. ඒ කියන්නේ මේ ප්ලග් එක ප්ලග් টොප් එක මේ පැත්තට හරවනවා. දැන් මේකේ අර මේව ටික ඇතුළට යන්න පුළුවන්ද? යන්න බෑ. right? එතකොට රියැක්ෂන් එකක් වෙන්න පුළුවන්ද? යන්න බෑ. orientation. ඒ කියන්නේ රියැක්ෂන් එකක් වෙනකොට orientation එකක් තියෙනවා. දැන් මෙහෙම හිතන්නකෝ මේක මේ ෂේප් එකයි මේ ෂේප් එකයි හරිද? මේ ෂේප් එකයි මේ ෂේප් එකයි තිබ්බොතින් ඔන්න ප්‍රොඩක්ට් එක හැදෙනවා. හරිද? මේ ෂේප් එක මෙහෙම වැදුනොත් ප්‍රොඩක්ට් එක හැදෙන්නේ නැහැ. මෙහෙම වැදුනොත් නැහැ. මෙහෙම වැදුනොත් නැහැ. මේක මෙහෙම වදින්න ඕන. හරිද? That is what you call the orientation, right? You call that the orientation. So there has to be orientation. මොකද orientation එක තිබ්බේ නැත්නම් ප්‍රොඩක්ට් එකක් හැදෙන්නේ නැහැ. මේ දෙන්න කොලයිඩ් වෙන්න පුළුවන්. දැන් මෙහෙම තිබ්බත් කොලයිෂන්. දැන් මේක පළවෙනි පොයින්ට් එක කොලයිෂන් තමයි. කොලයිෂන් හරි. හැබැයි කොලයිෂන් එකෙත් මොකක් තියෙන්න ඕනද? correct orientation කියන එක තියෙන්න ඕන. Right. First thing is collision. Second thing is correct orientation of collision. Third thing is what? මොකක්ද? අරක මොකක්ද? මොකක්ද? What do you call it? නම් මෙහෙම හිතන්න. හරිද? The third thing is if you are plugging this, right? If you are plugging this හිතන්න වයසක අංකල් කෙනෙක් මේක ප්ලග් කරනවා කියලා. He doesn't have enough energy to do that. එතකොට එයාට මේක ප්ලග් කරගන්න බෑ. ඒක පෙනුජ යනවා කියලා. Goes and plugs it. That's all, right? So the reaction to occur, this has to connect with a certain energy. What do you call that energy? Yeah, the activation energy. That is the activation energy. ඔන්න ඔය තුන තියෙනවා නම් අනිවාර්යෙන් ප්‍රොඩක්ට් එකක් හැදෙනවා. Get it? Those are the three necessities. What are the three necessities for a reaction to occur? Collision should be there. Correct orientation of collision. Activation energy has to be overcome, right? They have to overcome the activation energy. Those are the two necessary factors, right? So this is it. You can think about it in any other different examples as well, depending on your imagination, right? So many things are there. Oh, this guy is bad, right? The factors that affect the occurrence of a reaction, collision of reactants in the reaction. Now, online people, did you understand it? Shiny, Chanel, did you understand that point? The collision theory. This is called the collision theory as well. The whole thing. This you call the collision theory. මේ කියන්නේ මේ 1 2 3 කියන තුනටම කියන්නේ collision theory කියලා. Chanel understood? Yes. Shiny? Dishmita? Understood that theory? That's very important, no? Because there will be questions on that. So collision of the reactants in the reaction, having the right orientation, and reactant exceeding the activation energy barrier should be there, right? Okay. Come to this part. The minimum amount of energy that must be supplied to reactant for it to become a product is called the activation energy. We already discussed this. It acts as an energy barrier. अब मेवा discuss कला थी, नहीं? Right. The next topic, factors affecting the speed of reaction. ඔය දෙක පටලවා ගන්න එපා. මේක වෙන එක. මොකද්ද මේ? Factors affecting the speed of reaction or the rate of reaction. Now, factors affecting the rate of reaction are 4 things. Right? 4 factors are there. What are the 4 factors? Temperature, concentration, nature of the reactants, presence of catalyst. right?
surface area එකක් උදාහරණයක්.
ඒක තමයි nature of the reactants. Surface area කියලා කියන්නේ nature of the reactants, right? So what are the four things? Temperature, concentration, huh? Nature of the reactants, yeah, presence of catalyst, right? ඔය හතර තමයි factors. ඊළඟ point එක තමයි listen, right? මෙන්න මේ temperature, concentration, ඊට පස්සේ nature of the reactants, presence of catalyst කියන හතර දෙනා නිසා rate of reaction එක වැඩි වෙන්නේ. අර collision theory එකෙන් explain වෙන විදිහට. හරිද? කියන්නේ collision theory එකේ තියෙනවනේ තුනක්. collision, orientation, activation energy. එතකොට අපි අර temperature, concentration, surface, nature of the reactants කියන ඒවායින් rate of reaction වැඩි වෙන විදිය explain කරන්න ඕන collision theory එක පාවිච්චි කරලා. Right? That is the next thing. හරිද? Now let's come to the temperature. Now how do you explain the effect of temperature for the rate of reaction?
Temperature conditions වැඩි.
අන්න හරි. temperature එක වැඩි වෙනකොට collisions වැඩි වෙනවා. ඇයි? reactants වල මේ reactants වල තියෙන speed එක මොකද වෙන්නේ? kinetic energy එක වැඩි වෙනවා. එතකොට number of collisions are increasing. So there is a higher chance of reacting. Then the products are produced. That means the rate of reaction is increased. Right? That is how it happens. Yes. Another way of no. There's another one of temperature. What is the other one? One is the number of collisions are increasing, improving. There's another thing. Yes, when the temperature increases, the activation energy, no, I'm sorry, not activation energy increase when the fraction of molecules that exceeds the activation energy barrier is increased, right? The fraction of the molecules that, yeah, the activation barrier is increased, right? The fraction of the molecules overcome the activation barrier is increased or improved. Yes, that is how the rate of reaction is improved because of the temperature. Two of the factors are there. Correct? Right. So we are discussing those down there. And online people, did you understand that? The how you explain the rate, like how you explain the improvement of the rate of reaction because of these factors. You have to explain it using the collision theory, right? You have to explain. If you are asked to explain it, you have to explain it using the collision theory, right? Good, understood. Nice. So come to the temperature here, right? When the temperature is increased, the collision rate and the susceptibility of the molecules to react increase. Can understand that, right? Susceptibility is increased. The chance of, susceptibility means the chance of colliding is increased, right? Chance of colliding is increased, thus increasing the rate of reaction, right? Second thing is, as the temperature increases, the fraction of molecules, highlight the fraction of molecules, because not all the molecules are there in a same energy. They have different energy levels, right? So as the temperature increases, the fraction of molecules that exceed the activation energy increases. Get it? Right. Thus increasing the rate of reaction. Yeah. Next thing, the rate of reaction doubles for every 10 degrees of Celsius. You just keep it in mind. That's the extra theory. The rate of reaction doubles for every 10 degrees of Celsius increase in temperature. ඒ කියන්නේ 10 හැම කියන්නේ reaction එක rate එක double වෙනවා, temperature එක 10 degrees වලින් වැඩි වෙනවා. හිතන්න 10 degrees 20 වල තියලා 30 වලට යනකොට reaction rate එක double වෙනවා. 30 වල ඉඳලා ආපහු 40 වලට යනකොට ආපහු ඒ තියෙන amount එක ආපහු double වෙනවා. ඒ විදිහට rate of reaction එක double වෙවි යනවා every 10 degrees වලින්, right? ඒක extra theory එකක් විදිහට තියාගන්න. හරි. keep it as a extra theory. right. right. මෙන්න මේකට එන්න. ඊළඟට එන්න concentration කියන එක. හරිද? The second is what? Concentration of pressure in gaseous reactors. ඒකත් වැදගත්. ඒ කියන්නේ concentration එක කොහොමද effect වෙන rate of reaction එක. Give me your ideas.
දැන් concentration එක වැඩි වෙද්දී ඒත් අර happen තියෙන chance එක වැඩි වෙනවා.
Yes, yes. The susceptibility increases, right? That is true. Hi. Yeah, don't worry about it now. Consider the concentration, huh? Okay. Yeah, the susceptibility of collision is increased when the concentration is increased. That is a true answer. That's correct. Susceptibility increases. The chance of colliding. Hey, collide වෙන තියෙන chance එක වැඩි නේ. ගොඩක් කට්ටිය ඉන්න හින්දා නේ. It's like අපි හිතමු මෙතන in this room, let's say girls and boys are like both the girls and boys are there, right? But let's say there's only few girls, like 2-3 girls are there, and the number of boys are very high. Let's say 50-60 or number of boys are there, only 2-3 girls are there. So the susceptibility of collision, if we say the girls finding a boy for a relationship is the reaction, we can call it a reaction. So the susceptibility is less. Why? Podda concentration එක අඩුයි. But if there is more of both the girls and boys, the susceptibility of a reaction or a collision is high. Simple as that, right? That's how the concentration affects, right? If more the concentration, more the chance of collisions, right? That is how the concentration is effective. Get it? Right, good. Temperature, we'll come to that. Yeah, concentration, pressure. As the concentration of a reactant increases in a reaction, the rate of the reaction increases. That is, the number of collisions of the reactant increase, right? The rate of the reaction increase because the number of collisions occurring per unit time increases, right? Hari. And the pressure. How is the pressure affecting the concentration? In the theory, it says concentration of the reactants, or if it is gaseous reactants, the pressure of the reactants, right? If it is gaseous, instead of concentration, what do we take? We take the pressure. And how is pressure affecting the rate of reaction in gaseous reactants? Oh, it is more like the concentration. Right? Pressure is more like the concentration. Why? Let's say you are taking a balloon. Reactants, the gaseous reactants are inside the balloon, right? Gaseous reactants are inside the balloon, and you are applying the pressure to it. You are applying pressure to it. What happens when you are applying the pressure to the balloon? The volume is decreasing. So the concentration increasing. Get it? So if it is gaseous reactants, the importance is when you apply pressure to a gaseous reactant, the gas can compress, right? Gas can compress. That means the volume will reduce, so the concentration will rise. Get it? That is why the pressure is affecting the gaseous reactants. When you apply the pressure, concentration will rise because the volume is reducing. Take the balloon example. If the reactants are inside a balloon, if you apply the pressure, volume will reduce. That means concentration will rise. Get it? Simple as that. Very simple theory, right? So as pressure of gaseous reactant increases, the rate of reaction increases, right? And similarly, when the volume of a gaseous system is reduced, the pressure increases while the factors remain constant. Pressure එක වැඩි කරනකොට මොකද වෙන්නේ? Volume එක අඩු වෙනවා. Pressure එක වැඩි කරනකොට volume එක අඩු වෙනවා. So the concentration increases and the rate of reaction වැඩි වෙනවා. In gaseous system, the pressure increases with the increasing temperature, right? In a gaseous system, pressure එක වැඩි වෙනවා. Pressure increases with the increasing temperature. එහෙමත් වෙනවා. හරිද? temperature එක වැඩි කරනකොට අර molecules වල තියෙන kinetic energy එක වැඩි වෙනවානේ. බැලුම් එකක් එකකින් අර expand වෙලා පුපුරන්නේ. temperature එක වැඩි කරනකොටත් pressure එක වැඩි වෙනවා. ඒගොල්ලෝ අර correlated නේ. temperature එකයි pressure එකයි correlated වෙලා තියෙනවා. And all the other factors remain constant, right? That's it. And the physical nature of the reactants. I'll come to the physical nature of the reactants. As the surface area of the reactant increases, the space available for the reactant molecules to react increases. Now this is something like this. Let's say you are dissolving a crystal of salt, a very large one, and a powder, right? But the same amount. Let's say you are taking a 50 grams of a salt crystal, right? And 50 grams of salt powder, and you are dissolving it in the same amount of water. What will dissolve faster? Powder or the crystal? The powder will dissolve faster, right? Why? Surface area වැඩි. ඒ කියන්නේ දැන් crystal එක තියෙනකොට crystal එක ඇතුළේ අර hindered particles or the hidden particles are too much නේ. ඒවට water molecules යන්න බෑනේ. surface එකත් එක්ක විතරයි water molecules වලට react කරන්න පුළුවන්. But when you reduce the particle size or when you make it a dust powder, the surface area is increased so that all that other water molecules can react with the all the the crystal or the salt particles නේ. ඇයි ඒ ටික දැන් අර හින්ඩ වෙලා තිබ්බ ටික ඒකල දැන් එළියට ඇවිල්ලා. ඒ එළියට එනකොට surface area එක තමයි වැඩි වෙන්නේ නේ. මෙන්න මේක තියෙනවා වගේ මේ මැද තියෙන ඒවට මෙයාට approach කරන්න බෑ. හැබැයි powder වෙච්ච ගමන් ඒකට approach කරන්න පුළුවන්. So more reaction occurs. That is the difference of powder and crystal. So powder මේ කියන්නේ මේ surface එකේ react කරනකොට chance එක නැහැ ඇතුලේ ඉන්න ඇත්ත එක react කරන්න. පස්සේ යනවා. පස්සේ යනවා. ඒ කියන්නේ බැරි වෙන්නේ නැහැ. පස්සේ react කරනවා. ඒ කියන්නේ මුලදී chance එක නැහැ යාට. powder කරලා දැම්මම පස්සේ chance එක වැඩි. හරිද? powder කරලා දැම්මම පස්සේ chance එක වැඩි. Right. බලන්න ඒක as the surface area of the reactant increases, the space available for the reactant molecules to react increases. That is what happens, right? So that is the area where molecules collide increases, right? මෙතන molecules collide වෙන amount එක මෙතනට වඩා ගොඩක් වැඩි. Get it? Yes. The other thing is catalyst, right? Presence of catalyst. Catalyst. Come to the catalyst. So what is a catalyst and what does the catalyst do? Speed එක වෙනස් කරනවා. What else? කොහොමද වෙනස් කරන්නේ? ස්පීඩ් එක වෙනස් කරන එක හරි.
අර ඇක්ටිවේෂන් එනර්ජි මොනවාද?
that's true. හරි.
හා.
ඒ කියන්නේ කැටලිස්ට් එකෙන් කරන්නේ මොකද්ද? කැටලිස්ට් එකෙන් කරන්නේ ඇක්ටිවේෂන් එනර්ජි එක අඩු පාත්වේ එකකින් රියැක්ෂන් එක අරගෙන යන එක. ඇක්ටිවේෂන් එක එනර්ජි එක අඩු පාත්වේ එකකින් රියැක්ෂන් එක අරන් යන එක තමයි කැටලිස්ට් එකෙන් කරන්නේ. අපි ඒකට කියනවා එයා mechanism එක change කරනවා. reaction එකේ mechanism එක change කරනවා. It's something like this. Let's say this is the energy barrier. This is a mountain and you are a biker. Bike or me runner hari එහෙම ගන්නකො මොකක් හරි. So you're driving a bike now here. This is a bike. So you supposed to come to this point. So once you come to this point, you have to like apply energy up to this point. And once you came to this point, can easily finish the finishing line or the product. මෙතනට ආවම පස්සේ තමයි යාගේ production එක finish වෙන්නේ. This is the product, this is the reactants, right? So you have to climb the mountain, and once you come to the top, you be freely go to the finishing or the product, right? Now this is the activation energy, the barrier, energy barrier. This is the highest energy you're supposed to take, right? And right. අපි හිතමු දැන් Penuja is trying to climb the mountain. හරිද? දැන් okay. හරිද? Penuja is trying to climb the mountain to win the race. This is the reaction. හරිද? This is the reaction. So මේක climb කරලා මෙතනට එන එක තමයි winning. මෙතන තියෙන reactants, මෙතන තියෙන්නේ product. Right? එතකොට let's say Yuhasa comes and telling Penuja, bro, there's another way of doing that. You can simply go this way. You don't have to go all the way up. I will show you a different way. Come here. No, not a tunnel. A shortcut. Right? So මේ shortcut එකෙන් යන් කියලා she's asking. So Penuja is going. එතකොට මෙතන තියෙන activation energy කොච්චරද? මෙච්චරයි. ඒක මෙයාට වඩා අඩුයි. So this is a different mechanism or different pathway. That is what the catalyst does, right? That is what the catalyst does. It changes the reaction pathway. It takes the reaction in a low activation energy path. Get it? It takes the reaction in a low activation energy path. It does not change the activation energy, but it takes the reaction in a low activation energy path. That's it. Get it? Energy එක අඩු path එකකින් අරන් යනවා කියන එක. Change කරන්නේ නැහැ නේ මේක මෙහෙමම තියෙනවා. එයා වෙන low energy path එකකින් යනවා. Right? That is what the activation, like the catalyst does. Get it? Good. තියෙනවා. මම අපි ඉස්සරහට යනවා. තියෙනවා. I'm coming to that point, don't worry. Tute එකේ තියෙනව නේද අහන්නේ? Tute එකේ තියෙනව නේද අහන්නේ? හරිද? ඒ ටික understand the but in the presence of catalyst, a reaction occurs via a pathway with lower activation energy, resulting in an increase in the fraction of reaction that exceeds the activation energy. Here the catalyst forms a low energy activated energy complex or the transitional state. ඒ කියන්නේ අර මෙන්න මේක දැන් අපි කතා කරේ අර මැද පාරකින් යනවා කියලා. ඒතර එයා කරන්නේ මොකද්ද? low energy activated energy complex නැත්නම් අර low transitional energy state එකක් එයා හදලා දෙනවා. අපි අර transitional energy state එකක් කතා කරා මතකද? අර jump එකකින් පස්සේ උඩ තියෙන කෑල්ල ඒක transitional energy නේ. ඒ jump එකේ තියෙන transitional energy එක පල්ලෙහාකට ගන්නවා. ඒක තමයි කරන්නේ. හරි. පල්ලෙහාකින් යනවා. right. හරි. ඊට පස්සේ අපි අර graph ටික කතා කරන්න ගමු. හරිද? Come to the first graph of temperature. මෙන්න මෙතනට. හරි. ඒ ටික understood නේ? People online, did you understand the whole thing? How it was affecting? නේ? Right. Online people, you tell, did you understand it? Good, shiny, yes, nice, very good. So come to this temperature graph, right? So how the rate of reaction change with the concentration and time, right? So this is how it usually change, right? This is how it usually change, concentration and time. So let's say the reaction is A plus B producing C, right? And this is how the concentration is changing with the time. It's not a straight line. That is one of the main things you should understand. It's not a straight line. It's a curve, which means the rate of reaction is not a constant value. අපිට straight line එකක් આવොත් constant value එකක් එන්නේ. ඇයි? මේ graph එකේ හැටියට concentration over time එකනේ මේ එන graph එක. මේ පෙන්නන්නේ concentration time නම් axis දෙක graph එක තියෙන්නේ concentration over time, which means rate of reaction, right? Which means rate of reaction. එතකොට මේ rate of reaction එක change වෙන විදිය තමයි මේ graph එකේ තියෙන්නේ. Get it? එතකොට now this is the thing. Make a straight line නෙමෙයි. It's a curve, which means the rate of reaction is not a constant value. It has changed. When the concentration is changing, the rate of reaction has also changed. එතකොට beginning එකේදී බලන්න මෙන්න මේ දෙක compare කරන්න. හරි. මෙන්න මේ understanding එක ගන්න. Compare the very beginning. මේ තියෙන reactant එක හොඳයි. A plus B තමයි මේ තියෙන්නේ. A plus B වල concentration එක එන්න මොනවා වෙලාද? අඩු වෙලා මේ පල්ලෙහාට අඩු වෙන්නේ concentration. මේ පැත්තට time එක යන්නේ. අපි compare කරමු මෙන්න මේ පොඩි period එකක්. මෙතනයි මෙතනයි. හරිද? එතකොට difference එක එන්නේ මෙන්න මේ දෙක. හරිද? මෙන්න මේ දෙයක් වගේ ගන්න. හරිද? මේ තියෙන්නේ delta T time එක. concentration difference එක තියෙන්නේ මෙන්න මේ ටික. මේ තියෙන්නේ delta C concentration difference. මට කියන්න මෙතන concentration difference එකේ gap එක වැඩි. time එකේ gap එක අඩුයි. නේ? concentration difference එකේ gap එක වැඩි, time එකේ gap එක අඩුයි. එතකොට මේ දෙන්න divide කරොත් එන්නේ rate of reaction. එතකොට rate of reaction එක මේ දෙන්නගේ gap එක වැඩි, මෙයාගේ gap එක අඩුයි කියන්නේ rate of reaction එක වැඩිද අඩුද? වැඩි. ඇයි? අපි concentration over time නේ rate of reaction කියන්නේ. මෙයාගේ gap එක වැඩි, මෙයාගේ gap එක අඩුයි කියන්නේ rate of reaction එක වැඩි. good. right. මේ තියෙන්නේ initial කියන්නේ මෙන්න මේ මුල time එක පටන් ගන්න මුල් ටිකේ. අපි time එකට චුට්ටක් යන්න දීලා බලමු. මේ හරිය වගේ time එකක් ගමු. මේ හරිය. හරිද? බලන්න මෙන්න මෙතන compare කරොත් එතනයි මෙතනයි ලොකු concentration difference එකක් තියෙනවද ඒ time gap එකේ? එහෙනම් චූටි concentration difference එකක් තියෙනවා. මම මේක delta C1 delta C2 කියලා ගන්නම්කෝ. මේ තියෙන concentration difference එක. හැබැයි time difference එක මොනවා වෙලාද? time difference එක වැඩි වෙලා. නේ? time difference එක වැඩි වෙලා. එතකොට අන්තිම ටිකේදී ගත්තොත් concentration difference එක අඩුයි, time difference එක වැඩි. ඒ කියන්නේ rate of reaction මොනවා වෙලාද? අඩු වෙලා. ඒ කියන්නේ time එකත් එක්ක concentration අඩු වෙනකොට rate of reaction එන්නේ මොනවා වෙලාද? අඩු වෙලා. ඕනම reaction එකේ එහෙමයි. reaction එක වැඩි මුලදී. අන්තිම ටිකට යනකොට මොකද reaction එක slow වෙනවා. හරි? ඒ concentration අඩු වෙනවනේ. එතකොට අර react කරන්න තියෙන chance එක correlation theory එකනේ. එතකොට අගට යනකොට මොකද වෙන්නේ rate of reaction අඩු වෙනවා. Get it? Good. So මේක තමයි typical rate of reaction graph එක. මේ තියෙන්නේ reactants වලින්. reactants එන්නේ මොනවා වෙනවද? This is depending on the products. C is the product. A plus B producing C. So initially product 0 නේ. හැදිලා නැහැ නේ. ඊට පස්සේ time එකත් එක්ක products හැදෙන්න ගන්නවා. rate එක අඩු වෙලා තමයි අන්තිම ටිකේදී හැදෙන්නේ. මුලදී හැදෙන rate එක වැඩි, අන්තිමට හැදෙන rate එක අඩුයි. Get it? Right. So the next thing is temperature එකේ impact එක. හරිද? temperature එකේ impact එක. If you increase the temperature, what will happen to the graph? What will happen to the rate of reaction? දැන් මේ තියෙන්නේ normal reaction එකක concentration time graph එක. මේකේ මම temperature එක වැඩි කරන එක තමයි දැන් කරන්නේ. So if I increase the temperature, what should happen to the rate of reaction? It should increase. නේ? If I increase the temperature, rate of reaction should increase, right? Rate of reaction should increase. Now how do you draw it in the graph? How do you draw it in the graph? another color. Huh? Same way. Time එක මොකක් වෙන්න ඕනද? products හැදෙන කාලේ අඩු වෙන්න ඕන. reactants react කරන time එකත් time එක අඩු වෙන්න ඕන. දැන් මේකේ rate of reaction වැඩි වෙනවනේ. rate of reaction කියන්නේ concentration difference over time. temperature එක වැඩි කරාම අපි දන්නවා simply rate of reaction එක වැඩි වෙනවා. concentration difference එක වෙනස් වෙන්නේ නැහැ නේ. ඒක value එකක්නේ. හැබැයි ඒ concentration difference එක වෙනස් වෙන time එක අඩු වෙනවා. ඇයි? ඒ concentration difference එකම අඩු time එකකදී react කරනවා. හරි? අඩු time එකකදී ඒක react කරනවා. ඒ කියන්නේ මේ graph එක මෙහෙමනේ එන්නේ. මේක time එක පැත්තට ඉස්සරහට යන්න ඕනද? time එක පැත්තට පිටිපස්සට එන්න ඕනද? දැන් මේකනේ normal graph එක. temperature එක වැඩි කරාම පස්සේ rate of reaction වැඩි වෙනවනේ. එතකොට මේ graph එක time එකෙන් ඉස්සරහා පැත්තට එනවද පිටිපස්සට යන්න ඕනද? Did you understand that? දැන් මේ තියෙන්නේ normal rate of reaction. temperature එක වැඩි කරාම පස්සේ rate of reaction එක වැඩි වෙන්න ඕන. rate of reaction එක වැඩි වෙනවා කියන්නේ time spent කියන එක වැඩි වෙන්න ඕනද අඩු වෙනවද? අඩු වෙන්න ඕන. එහෙනම් graph එක time එක පැත්තෙන් පිටිපස්සට දාන්න ඕන ඉස්සරහටද? ඒ කියන්නේ මේක මොකක් වෙන්න ඕනද? initial final දෙක වෙනස් වෙන්න පුළුවන්ද? amounts බෑනේ. හැබැයි මෙයා චුට්ටක් පිටිපස්සට එන්න පුළුවන් මෙහෙම. get it? ඔන්න ඔහොම වෙන්න පුළුවන්. මේ තමයි මාක් කරාමද temperature එක වැඩි කරාම graph එක. get it? Be brainful nah? brainful. I mean simply use your brain. Huh? තේරෙනවා. Now this is the thing again, take it logically as much as possible. ඒකට brain එක focus එකේ තියාගන්න ඕන. මේකට. You can't let the inner voice may struggle with you. නේ about උදේ කාපු පාන් එක හරි නේ මේ සුද මොන හරි තියලා ආපු ඒවා හරි බස් එකේ දැක්කපු අයියව හරි you can't think about everything at this point. මොකද මේක you have to be really calm, really focused and really logical to understand something like this. That is the nature of it. Right? That is why you tell that when you learn scientific things, you have to sacrifice the fun or the things that you think, and you have to give me space to think, so you understand it. That is how it happens. You can't be a hanky panky and do this. You can be hanky panky after the time. No, not even after the time. You can be hanky panky after the time you give for this, right? For the studies and learning. When you are studying and learning, when you are in the table studying, you have to focus. And when you are learning in the board, you have to focus. Now, after everything, after that, you can do any hanky panky things if you want, doesn't matter. But when you are learning and studying, you have to give the maximum focus. Oh, there is no point of doing this. You will not learn, not anything, but you will not learn the necessary level. Yeah, right? So that's it. So if I draw this graph, it should come to back or forward. So this is high temperature graph, right? මේ label කරලා තියෙන්නේ ඒක. දැන් මේ තියෙන්නේ normal graph එකක්. හරිද? එතකොට ඒකෙම temperature වැඩි කරාම පස්සේ තියෙන එක තමයි මේ යටින් යන්නේ. හරි. ඒ දෙක කලස් දෙකකින් දාගන්න. දැන් ඔයගොල්ලන්ගේ එකම කලයකින් තියෙන්නේ. හරි. කලස් දෙකකින් දාගන්න. කියන්නේ temperature එක වැඩි එකයි අඩු එකයි හරියට දාගන්න බලන්න කලස් දෙකකින්. හිතලා දාන්න මම කියන්නේ මොකද්ද කියලා graph එක. දැන් මම මේක ඇඳා. මේකේ ඔයා label කරගන්න පාට දෙකකින් එකක් රතු පාටකින් වගේ දාගන්නකො. ඒ කියන්නේ temperature එක වැඩි වුණාන් පස්සේ රතු පාටින් draw කරන්න. එතකොට හරි. රතු පාටින් draw කරලා ලියන්න වෙන පාටින් හරි කමන්නේ draw කරලා ලියන්න මේ when the temperature is increased කියලා. Did you understand the graph? ඒක තේරෙනවද graph එක? Right? People online, did you understand the graph, how the graph works? Dishmita, Shinal, Shiny, did you understand the graph? Yes, Dishmita, good. Nice, 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 nice. All good? All good? Yeah. I can see and I do understand you have a sort of a mind setups inside because I've been there. But you should try your maximum to focus on the studies. And now at least when it comes to the learning and studying, it's a certain time that you'll be giving. A time make it, you have to get rid of the dogma inside your brain or your mind. Try maximum to be focused. I'm not telling you, I'm telling as a whole. Right? Right, so that's the graph. Now come to this one. This is you call as the Boltzmann curve, right? This you call as the Boltzmann curve. So Boltzmann curve is something about the distribution of the any of integers in a sample, right? The distribution of the integers in a sample. Integers කියන්නේ ඒකේ තියෙන numbers මොනවා හරි. කියන්නේ අපි හිතමු ස්කූල් එකේ ඉන්න ළමයි නම් integers වෙන්නේ integers කියන්නේ මේ ඉන්න number එක. Integers ටික කියන්නේ ඔය දැන් ස්කූල් එක නම් integers කියලා කියන්නේ ඒකේ ඉන්න ළමයි ගාන. ඒ වගේ. ඒගොල්ලන්ගේ distribution තියෙනවා. ඒ sample එකක් කියලා හිතන්නකෝ. ඒ samples වල distribution තියෙනවා. ඒ distribution එක හැමතිස්සෙම එන්නේ bell curve එකකට කියලා තමයි Boltzmann කියන්නේ. හරිද? එයාගේ theory එක ඒක. කියන්නේ ඕනම distribution එකක් bell curve එකකට යනවා. හරිද? මෙන්න මෙහෙම shape එකක් ගන්නවා කියලා තමයි කියන්නේ. හරිද? මේ තියෙන්නේ number එක නැත්නම් fraction එක. මේ පැත්ත දාන්නේ fraction of number. මේ පැත්තට ඔයාලට ඕන එකක් දාන්න පුළුවන්. අපි දුම් මෙහෙම sample එකක්. ස්කූල් එකක ඉන්න ළමයින්ගේ height එක. හරිද? ස්කූල් එකක ඉන්න ළමයින්ගේ height එක ගොඩාක් වෙන උස දඩයුන් ඉන්නේ චුට්ටයි. හරිද? මේ පැත්තට එතකොට අපි දාන්නේ height, මේ පැත්තට දාන්නේ fraction එක. එතකොට මේ area එකෙන් පෙන්නන්නේ මුළු number එක. එතකොට ගොඩාක් උසුන් ඉන්නේ මේ පැත්තට උස වැඩි වෙනවනේ. ගොඩාක් උසුන් ඉන්නේ මෙන්න මේ චුට්ටේ. ගොඩාක් කොට සෙට් එකේ ඉන්නේ මෙන්න මේ සෙට් එකේ. මේක දෙන්නෙක් මෙන්න. හරිද? මෙන්න මේකේ තමයි. හරිද? ඒතර ගොඩක් ඉන්නේ කවුද? average එකේ අය. Good. Average? Okay. හරිද? So average එකේ තමයි වැඩිපුරම ඉන්නේ. ඒක වගන්න weight කියලා. If you take the weight, ගොඩාක් weight එවුන් ඉන්නේ චුට්ටයි. දැන් very low weight ඉන්නේ චුට්ටයි. ඔයත් very low නෙමෙයි. ඔයත් ඉන්නේ average. Average weight එකකින් ඉන්න අය තමයි average. So all the distributions will be like this of any of the samples. That is what the Boltzmann said. Distribution එක කියන්නේ bell curve. ගොඩාක් අර වැඩි අය ඉන්නේ චුට්ටයි, ගොඩාක් අඩු අය ඉන්නේ චුට්ටයි. Everyone will be in a average. So now this curve we take it for the fraction of molecules and the energy. අපි හිතමු මොකක් හරි reactant sample එකක් ගන්නවා. ඒ sample එකේ මේ තියෙන්නේ fraction එක. ඒ කියන්නේ මේ පෙන්නන්නේ number of molecules. මේ පැත්තට දානවා energy. හරිද? මේ පැත්තට දාන්න මොකද්ද? energy. හරි. දැන් මේකේ බලන්න මේ ඔක්කොම molecules නේ. එතකොට මේ surface area එක completely අපි කියන්නේ molecules, number of molecules කියන එක. මෙන්න මේ හරියෙන් පෙන්නන්නේ high energy එකක ඉන්න molecule fraction එක. high energy එකක ඉන්න molecule fraction එකේ හරිම චුට්ටයි. very low energy එකක ඉන්න molecule fraction එකත් චුට්ටයි. average එකක ඉන්න molecule fraction එක තමයි වැඩි. එතකොට අපි මොකක් හරි sample එකක තියෙන molecules වල energy එක distribute වෙන විදිය ගත්තොත් this is it. Right? And activation energy is somewhere here. හරිද? activation energy is somewhere here. මෙතන තමයි activation energy. EA is here. Right? එතකොට මෙතනින් එහා තියෙන ඔක්කොම මොනවා කරනවද අනිවාර්යෙන්? They will react and produce the products. Get it? They will react and produce the products. Then මේ ටික එතකොට react කරන්න බැරි fraction එක. ඇයි ඒගොල්ලන්ට activation energy එකට තරම් energy නැහැ. මේගොල්ලන්ට activation energy එකට වඩා energy එක වැඩි. They will react. Now this is the thing. When you increase the temperature, what will happen? Energy එක වැඩි කට්ටිය වැඩි වෙනවා. Get it? When you increase the temperature, the number of molecules in a certain energy will be increasing. ඒ කියන්නේ මේ graph එක it will move to a or it will shift to a high energy state. ඒ කියන්නේ මෙයා මෙන්න මෙහෙම ඉස්සරහට යනවා. හරිද? අන්න එහෙම ඉස්සරහට යනවා. එයා shift වෙනවා. high energy state එකකට shift වෙනවා. හරිද? එයා මොකද වෙන්නේ? high energy state එකකට shift වෙනවා. මෙන්න මෙහෙම යනවා. කවන්නේ ඒක අපි මේ පාටින් මදිමුනේ. මෙන්න මේව high energy state එකකට shift වෙනවා. හැබැයි මේ graph එකේ area එකයි මේ graph එකේ area එකයි වෙනස් වෙලා නැහැ. Same area. Same area means number of molecules are same. හැබැයි බලන්න මෙතනනේ activation energy එක තියෙන්නේ. මෙතන තමයි activation energy තියෙන්නේ. දැන් activation energy එක overcome කරපු හරිද? activation energy එක overcome කරපු number of molecules දැන් මොකක් වෙනවද? දැන් කලින්ට වඩා වැඩි. activation energy එක overcome කරපු number of molecules is now more than the previous. Get it? Is now more than the previous. The temperature එක වැඩි කරාන් පස්සේ rate of reaction එක වැඩි වෙන්නේ මේ විදිහට. ඇයි? කලින් react කරේ මෙන්න මේක. මේ number එක. මෙන්න මේ ටික. හැබැයි දැන් මෙන්න මේ ඔක්කොම ටික react කරනවා. හරි. ඒතර Boltzmann curve එකෙන් පෙන්නන්න කිව්වොත් temperature එක වැඩි කරාන් පස්සේ rate of reaction වැඩි වෙන්නේ කොහොමද කියලා. This is how you show it. Get it? Right. Come back to the theory. Right. These are the two graphs, right? එතන මේ තියෙන්නේ fraction of molecules and the energy. මේ තියෙන්නේ normal graph එක. room temperature එකේදී graph එක. මේ මොකද්ද? temperature එක වැඩි කරාන් පස්සේ graph එක. දැන් මේකේ මොකක් වෙලාද? කලින් activation energy එක පැනපු අය කොච්චරද මට පෙන්වන්න බලන්න මේකේ. A ද B ද? A තමයි කලින් activation energy එක පැනපු කට්ටිය. දැන් temperature එක වැඩි කරාන් පස්සේ graph එක shift වෙනවා energy එක වැඩි පැත්තට. ඒ කියන්නේ දැන් activation energy එක overcome කරපු fraction එක A plus B complete එක. හරි. අපි ඒක මෙන්න මේ පැත්තට ටිකක් ගහගන්න. එතකොට මේ දෙක වෙන් කරලා පේනවනේ. මේක මේ පැත්තට ටිකක් ගහගන්න. Right. So the fraction that exceeds the activation energy at room temperature තමයි මේ. මේ තියෙන්නේ මොකද්ද? The fraction that exceeds the activation energy at temperatures above the room temperature තමයි මේ තියෙන්නේ. Got it? Nice. Yeah. අපි 1.10ට වගේ ඉවර කරමු. හරි. 1.10ට වගේ ඉවර කරමු. හරිද? Understood it? Understood the graph? Good. Now come to the next graph. මෙන්න මේක. මේක ඔයගොල්ලෝ දන්නවනේ. මේ තියෙන්නේ normal reaction එකේ path එක. මේ තියෙන්නේ යාගේ activation energy එක. මෙයා මොකද්ද? කවුරු ඉන්නකොට path එකද මේ තියෙන්නේ? catalyst එකක් ඉන්නකොට path එක තමයි මේ තියෙන්නේ. හරිද? එයා මොකද කරන්නේ? අඩු transitional energy එකක් තියෙන path එකකින් reaction එක අරගෙන යනවා. right? right. මේ තියෙන්නේ එයාගේ graph එක. මේ තියෙන්නේ Boltzmann curve එක. මේ Boltzmann curve එකේ මේ තියෙන්නේ activation energy 1 එක. ඒ කියන්නේ normal pathway එකේදී normal reaction එකේදී activation energy එක තියෙන්නේ මෙතන. එතකොට එතනදී ඒ activation energy එක pass කරපු අය ඔක්කොම react කරනවා. ඒ කියන්නේ එතනදී react කරන්නේ මෙන්න මේ ටික විතරයි. නේ? මේගොල්ලෝ විතරයි. activation energy 1 එකේදී react කරන්නේ මෙන්න මේගොල්ලෝ. get it? හැබැයි ඔයා catalyst එකක් දාපු ගමන් මොකද වෙන්නේ? activation energy එක අඩු path එකක තමයි යන්නේ. ඒතර activation energy එක ඊට වඩා චුට්ටක් අඩු වෙනවා. මෙහෙට වැඩිනේ. මේ පැත්තට අඩු වෙනවා. දැන් අලුත් activation energy එක කොතනද තියෙන්නේ? මෙන්න මෙතන තියෙන්නේ. හරි. දැන් මොකද වෙන්නේ? දැන් react කරන amount එක කලින්ට වඩා වැඩි වෙනවා. හරි. react කරන amount එක කලින්ට වඩා වැඩි වෙනවා. get it? react කරන amount එක කලින්ට වඩා වැඩි. හරිද? එතකොට මේ fraction එක තමයි normal reaction එක. මේ තියෙන්නේ reaction with catalyst. get it? simple as that. yeah, මොකද එයා activation energy එක අඩු කරනවා. right? is reducing the activation energy. right. so yeah, next thing we have to discuss is multiple step reaction. අපි ඒක next week වලදී කතා කරලා we'll finish it. හරිද? මම elasticity tube එක දුන්නා.
ඒක දීලා.
හා?
ඊළඟ ඒක.
ඔව් මන් දුන්නේ නැද්ද? ඔන්න එනලා හම්බුණා. ඔකට හම්බුන්නේ නැහැ. එහෙමද? ඒක යවලා කියලා කිව්වා මේ මල්සි මට කතා කරා. මල්සිට ඒක අද හෝ හෙට හම්බේ. අනිත් අයට guys, did you receive the microbiology 2 by now? Shiny, have you received the microbiology 2 by now? I think all the rest have received, but you can rest of the tunes have received, but tell me if you have received the microbiology 2. ඒක යවලා කිව්වා තියෙන්නේ. Have you received it? No? Just tell me if you have received it. If tell me if you haven't received it, we'll check it. See what we'll have to do. And yeah, that's so far it. And shall we finish? So the next week we'll be finishing the rate of reaction as well, and I have given you the question bank too. And you maybe you have මන් දුන්නා මෙහි ඇති කලෙක්ට් කරගන්න. ඒක දැන් කරන්න ගන්න. හරිද? ඒක දැන් කරලා ඉවර කරන්න. ඒකේ ප්‍රශ්න ටිකට උත්තර ලියන්න. Be brainful and මේ අර always be present at the moment that you do. හරිද? අර brain එකට ඔහි හිමේ යන්න දෙන්න එපා. No point. I can see that all the time. Don't let that happen, right? So you study, do the questions, and try to improve a little by little, because you don't have much of a time. You don't have much of time, and you have a certain period of time. That will be, yes. So you have like 9 to 8 months to go. පොඩ්ඩක් නෙමේ time එක relative. The time එක relative. So you start working. You start working and you'll be fine. Right. So we'll see you guys on next week. We'll be finishing the rate of reaction, the kinetics by next week, and we'll be starting a new lesson. And start doing the question bank, please. Finish all the questions. Hold on. ask somebody to come here and switch off the camera. No. Guys, see you online. Adios. You have it now? Ah, yes. Yeah, sure.